fine and clear because this is the first time I try the new setup. I have made some changes and I now have a little bit more, I don't want to say professional, but maybe a little bit more prosumer setup. Mostly so that the microphone is not on my way anymore when I type and do stuff. I'll wait a little bit more time to make sure everybody joins us. Today I'm going to be playing around with CircuitPython a little more again, like it's not the first time and it's not going to be the last time either, because I don't think I'm going to get to the end of the CircuitPython stuff today. I'm also planning on streaming longer than usual, simply because there is nothing else going on today much. My wife is currently out playing Pokemon Go. My feet are suggesting me not to, so I'm leaving that to her for now. And so I thought I would spend some more time looking at this particular problem, which is, as I started last week. Was it last week or 2 weeks ago? Time has been a bit of a mess. But to give a bit of summary, I have a device, or rather a chip, which is the SC16IS741A by NXP, which is a I²C controlled UART. It's a serial port controller over I²C. Now, most embedded MCU systems that you will use out there, that includes most of the stuff that runs CircuitPython, already come with hardware UARTs. So there is no reason why you will be using one, right? Except it doesn't always work the way you expect it to. On the ESP32, which is what I need to use for my aircon control panel replacement, the UART doesn't allow to send a very slow signal easily. And since the signal for that UART is 104 bps, the signal for the control panel is 104 bps, I need to be able to send something that slow, which basically I can't do with a ESP32 hardware UART because it's just too slow. It will refuse to send, well, not refuse to send it, but it will refuse to act correctly, and so it bunches up the bytes instead of sending them as they arrive. This would usually not be a big deal, but in this case it is, because I have strict timing requirements to be able to control the air conditioning and also to control the control panel. So to solve that issue, I just decided to go ahead and use a hardware UART with an I²C controlled chip, which is this thing, the SC16IS741A, which has both I²C and SPI, and it is this chip that you can see from the camera. You may notice that the camera setup is also slightly different than usual. I added a light. I'm actually not sure if I need to make this. Does this make any difference? No, it doesn't, except that this thing is very warm, so I'll take it out just because of that. So this is a LED array that you can see. Yeah, it's fairly bright. You can see the difference with or without it. Hopefully that will make the whole setup a little easier to deal with. So where were we? Yeah, this thing has the full support for the 5, 6, 7, 8-bit characters, even odd and no parity, 1, 1.5, and 2-bit stops. Like, it has nearly everything I need. It has a sleep current, which is very small, so it doesn't really add that much power despite being an additional component. And it has I²C bus and all the kind of thing. Like, it has fast speed for I²C bus. Fortunately, this is follower mode only or device mode only. And same thing for the SPI. It still use the old naming. But besides that thing, this works with both SPI and I²C. So depending on how you wire it, like it has, this is the I²C that I'm using. It also has the SPI support. If you lower this one, it has, what's the name of this one? Anyway, so that's a chip select, the clock, and the in and out. So all of that is fine if you want to use it on SPI. I'm using it on I²C simply because it's easier to wire, because I need 2 of them as well. Like if I only needed 1 SPI, it would probably be slightly faster. but I actually need these to work. Like I need two of these to work because I have two separate serial ports for that. Now, funny enough, I think there is a version that supports multiple serial ports, so I could use one of those instead of two. Let me see if I can actually find it. Because the Linux driver supports multiple serial ports on this thing. So this is the one I have. You can see it's not exactly cheap. It's like £2 each. So yeah, like it's not a deal breaker for the most part, but it's not exactly the cheapest option, and I don't want to waste these. I have two over here. Yeah, I actually got them at 185 instead of two because I bought 10 of these. There are other UARTs that you can look for. So if you look over here and you search for active dual UART, so number of channels 2. So this is the other part that may be interesting, and I will get to that later because yeah, that's going to be fun. And then if I go voltage supply, this is very wide, so I don't really need, I don't know how to do that. I don't care about any of the other stuff. Just find me anything that is in stock. So this one is another option. It's a dual UART 1.8 to 5 volts. Okay, minimum quantity 1000. Let's ignore that one for a moment. There is this one, which is the 752 BAB. I think this one may use the same protocol or something very similar. So you can see that it is different. Like this is an actual quad chip. So this is, what's the packaging for this one? I know it says that somewhere. Let me open this one. This is a LQFP 48. So my adapters for doing inline this one, so I can actually go ahead and use it on my breadboard, but it is a bit so this has 5 megabits per second, dual UART, 5 volts, 2.2 and 2.5. Yeah, you see this one has actually 3.3, not just 2.2. I don't know why that's 5, 2, and 2, and this one is 3.3 volts. Okay. Yeah, supports 5, 3.3, and 2.5 operations. I guess this was meant to be 3.3, not 2.2, which makes no sense. Congrats on XP. Maybe you want to correct this, but it's like this way for 11 years. Probably nobody has cared. And this is connected over something else. I don't think this is I²C, right? Yeah, this is data bus. This is actually parallel. So you can see it has the address here. Internal register for address selection, carrier detect, chip select, This is actually, yeah, you see D7 to D0. This is a parallel, like it parallelizes the serial port. It's very similar to the I²C. And to a point that this is literally the same. So it probably uses the same IP inside, but it doesn't have I²C on the other side. So I think when I was looking at this, I was looking for something that spoke I²C on the other side explicitly. And there are not that many dual UART for that. Let's see if I search no SPI no. Like if I look for dual UART, it doesn't actually find any of those. And then they get more expensive as well. Well, yeah, because even this one is like 410. And if you buy 10, it's still 4. So it's still more expensive than using two of the others. The other interesting part with this is that the FIFO is 64 byte. I have models with 3 bytes. Now I'm curious to see one. There is only one model with 3 byte. Oh yeah, this is pretty much impossible, I would say, to hand solder. You probably need an adapter. It's very expensive. It is max linear, whatever. Let's see what this one does. So this is a 2 full duplex independent channels. 8 general purpose output, because why not? I have 4 pin deep if you look for it. And the 28 deep. Okay, so that one is... this will be interesting, to be honest. but I don't think this is still available as a deep package. So this is serial to parallel, parallel to serial converters. This doesn't have I²C operation or anything. Yeah. Anyway, so there are dual options. They're not really that interesting for me. The reason why I was thinking of a 3 bytes FIFO is because here's the thing with this SC16, SC741. You can configure the level of FIFO when it fires out. So if I look to not the X, there is a FIFO level, Yeah, transmit FIFO level. Which defaults to 0x30. I don't remember why. What does that actually do? Transmitter FIFO level. There you go. Number of spaces available in the TX FIFO from 0 to 64. And I think there is trigger level register. I think that may be the right, yes. TX FIFO register, 4 to 60 number of spaces available. So when you set that one to 4, like it's a granularity of 4, and that's when it sends. So if I was to send it to set it to 4, and I was sending 6 bytes at a time, like once every second, if I understood that correctly, it's going to try to send the first 4, then it will cache the next 2, and then when I send the next 6, it will send 8 of them, because it does that on 4 granularity. That's annoying, that's not what I want, and that's one of the things I want to test. Because the protocol I need receives 6 bytes and sends 6 bytes. So I need to be able to get this granularity down to 2 or 3 would have been perfectly fine. So like 5 or 3 would have been fine because I would have sent all 3 and then it would have overflown and like it would have sent the other 3. For now, let's do one thing at a time. So back to coding. So this is where we were last time. And last time I started doing this with the pre-shifted addresses because there are free trailing 0-bit. That's actually only for the I²C and only for the single port one. So I'm going to just, for now, start doing a little bit of cleaning up of that. Yes, so that's the baud rate stuff. The other thing I want to do, let me go back to coding for a moment. No, to browsing, sorry. I want to find the CircuitPython API for get started libraries. No, those are all the libraries. Get started. Over here, yes. No. CircuitPython UART API. That's the bus.io. Maybe it's this one. One of these two. Bus.io, I²C, bus.io. That's the I²C bus. That's a one-wire bus. That's the SPI bus. Yeah, that's for the CS stuff. That's not what I want to use right now. UART, there you go. So this creates the parity and the stuff, all the stuff around the parity. I want to create the same exact parameters here because I want to use exactly the same API as the bus.io UART for this thing. Except that at first I may not support the 485 parameters because I don't have anything to test the RS485 with. So I don't want to start supporting things I cannot test. I can at least get the rest of the stuff working. Now, the other thing is Rx, TX, RTS, and CTS, those are not going to be present because this is actually an I²C or SPI device. So those four are not going to go there. What I want is all of this part over here. And this one is going to be a little bit more interesting because I don't know how the timeout is going to be. And I don't know how the receiver buffer size is going to look like yet. So let's start with the rest. This says optional parity, so I assume the bus IO also exposes parity. There you go. Odd and even, and it is considered a class deal. Does CircuitPython 7 have typing? It does not. So I wonder how they consider the optional on these things. Shared bindings, bus IO, class. Okay, how do they define optional? Import bus IO, dir bus IO. Probably they don't, or maybe it's just. I did on GitHub. Let's see what this one. Yeah, this one doesn't help, right? Actually, let me look for optional parity. It's declared that way, but it doesn't look like it's actually doing anything about it. You are subclassing, but your UART reports not supporting 9-bit data. Oh, that's interesting. So let me show you something. This says Dear Bosaya doesn't have a parity. And indeed there is no parity odd. Is there Basayo odd? There is no odd there. Which version of CircuitPython I'm using here? It says latest, and I'm on 7. Something's not quite the way I expected it. Because this says class basayo.parity, and this is revision 5A for A. Yeah, this is generated from the latest version, but it's not. Okay, so let me just start with going on Discord and ask. Like the fruit. asked it on the help with CircuitPython Discord channel because I'm like, this doesn't make sense to me. I may be wrong. So let's start with that. The other thing, I have various baud rate and stuff. In waiting, if we have the FIFO lists, essentially. It does enter and exit, but I'm not going to implement for now. It does have read into, read line, and write. This uses underscore typing. That may be why. Can I import underscore typing? No, I cannot. Yeah. Types for a C-level protocol. But I cannot implement. Like I cannot include it. Can I? That's a bit annoying. Yeah, because I want a writable buffer there. Oh, but R type is actually a return type. This is a bit strange. In fact, is this actually in the code? I don't know where it's getting this information from. Like, this documentation is not quite in the code. The docs feels a bit strange. Oh, look, there is a peripheral here. Ah, but it doesn't actually. Okay, never mind. Okay, let's go back to coding. Global buffer for reading and writing register with the devices. This is shared between all implementation classes to this memory application. Yeah, I'm going to have to change this one. This is going to be the basic class. And I'm also going to remove this shift by 3. And I'll show you why in a moment. So let's remove the thing by 3. This is going to be write buff. And it's going to be returning the line of the buffer for now. This is going to stand, like, for now I'm implementing single byte sending because I need to do that. Now this is the read drag and write drag, and I'm going to move this. So this is now the basic class, but actually it doesn't get I²C owner and address. And this stuff is going to be in a class SC16IS741A I²C. Or actually, I'm going to call this I²C like properly, with the idea that the way you import this, and I'm going to. Do I have a code open? No, I don't have a code open. Do I? No. So open media CircuitPython code.py. Over here, I'm going to import from my this import I²C as SC16IS7418. That way, for now this is not going to work, but the idea is that you can import either the I²C or the SPI and you get your own class. So back on this one instead. This is the I²C and this is deriving of that one. And this one is going to get this one has the read drag and write drag. going to have the actual init with that parameter over there, and that's going to be args, keyword args. Maybe going to be super self init args, keyword args. This one is not going to get the I²C at all. This one is going to get the parameters as defined in the UART, which is baud rate, parity. There is no optional parity. Is enum present? Import enum. There is no enum module, so this is not going to be able to do that. So this is going to also be an integer, and I'm going to do parity odd equal 0. Actually, no, parity non equals 0, just in case. Parity odd equal 1, parity even equal 2. And that's because I think the parity is going to be the same that way. Stop int equal 1. Does it say stop when number stop of bits 1 or 2? Technically this could be 1, 1.5, and 2, but for now let's keep it this way. This needs to be calculated, let's say, and this is the crystal clock. It needs to be an input, so I'm going to crystal clock, it's integer, and it's going to be, I'm going to default this to the one I have over here. This is the other thing I want to see. Like, I bought this particular crystal, like at this particular 1.8432 megahertz, because that's what was in the datasheet, and I was like, let me just get the same as in the datasheet. Now, but baud rate can go away from that. But the only problem with this is, oh, and I'm going to, is ABC present? ABC is not present. Def right reg register value is not implemented. And this is going to have read write the same way. So that way the I²C implementation is over here. Now, that's the other thing I need to do. Register is going to be register. This way, move by 3. And the reason for that is because there are 3 trailing zeros in this version. So yeah, these bits and parity and stop I need to actually calculate over here. That's, I think, so the LCR, let me do the calculation here so I can get this little closer. So this is the LCR register, the line control register. And ignore for a moment this divisor latch enable. Set parity and set break and set parity. I don't care for now. Set break is to actually send a break character, a break thing in the line. I don't think the UART variable implements it, so for now I'm going to ignore it. The set parity is to force the parity, so even if it is wrong. Even parity, so parity enable and even parity, these two sets the parity. So if you have parity set to none, these two are both 0. If you have parity set to odd, bit 3 is 1 and bit 4 is 0. And if parity is set to even, bit 4 is 1 and bit 3 is 1. So parity odd is 1 and parity even is technically 3 in this context. And parity non is 0. and that just needs to be moved 1, 2, 3 that way. So let's do that. Back to coding for a moment. So the LCR value is going to be, well, first we do if parity is known, parity is going to be parity known. That way we know that it's 0. If parity not in parity known, parity even, parity odd, because those are the only 3 values that actually make sense. Raise value error. We have F strings at least. We do not have F strings. We have dot format. We do have dot format. And that's going to be parity, sorry, dot format parity equal parity. Now the LCR value is going to be parity move, like left shifted 3, and then the rest of the bytes are, go back to the browser. So that takes care of, we don't care about this one, this one, this one, takes care of these 2 over here, and then we have stop bit, word length bit, and word, like these 2 are the word length. So the stop bit is the more interesting one because I don't quite remember how that one works. So let's check the line control register. Stop bit. Oh yeah, so depending on the word length, that is either 0 stop bits, sorry, 1 stop bit, 1.5 stop bits, or 2 stop bits, and that's depending on the word length. There is no control over that, so it's either 0 or 1. So that one is, I'm going to do the same here to check if stop not in 0, 1, oh sorry, 1 or 2, raise value error, value stop is not valid for not parity parameters, parameter for stop parameter, format stop equals stop, made as stop minus 1 moved by 2. So if it's going to be 1, it's going to be 0, otherwise it's going to be 1. And then it's going to be bits minus 5, I think, because yeah, see table 16. So 5 is going to be 0, 6 is going to be 1, 7 is going to be 2, and 8 is going to be 3. This does not support 9 bits. This only supports 5 to 8, so that's much easier. So it's going to be bits minus 5. I can do this left shift by 0 just to be clear. And then I'm going to go if bits not in 5, 6, 7, 8. There is value error. Oh, I'm showing you button right now. There you go. Value bits is not valid for bits parameter. Format bits equal bits. So that's going to be the LCR value. That's going to be the divisor value depending on the crystal clock. It asserts that the divisor is less than that. I'm going to actually make this a little bit easier. If the crystal clock is too fast and you want a too low value, things are not going to work. So for instance, let's see, if the crystal clock was 12 million and you divide it by 16 times 104, That's still fine, so I should be able to do that with 12 megahertz clock. But if I was to do this with yeah, if I was going to do it with 120 megahertz clock, or even 100 megahertz clock, probably. No, 100 megahertz clock, I can even use it. So I could use a clock generator, but eventually, if I'm looking for a very slow, very slow speed, like baud rate, and I have a very high crystal clock, I will need to divide this further. So for instance, let's go back to the datasheet. So I could set the divisor, sorry, the prescaler to 4. So in that case, as I said, on the 120, this wouldn't work if I wanted to have 104 bps I need with 120 clock. But if I was going to do this with the prescaler, it will still be valid. Now, the interesting part with that is I don't know if there is, let's see, is there a way for me to generate P32 clock generation? Like I could generate clock straight from a ESP32 and not need the actual clocks for that. So that will be an interesting option, right? Where ESP home clock generator, pulse counter, 7-segment display. I don't think there is a clock generator, right? There is a slow PWM or a softer PWM. It's a DAC. There is yeah, that's low PWM. Maybe this one. No, this is an output component. This is the software PWM. You can do 1000 hertz, and I assume that there is a way for me to do this and just have an actual PWM output with ESP home. Because that says there is a PWM driver. There you go. Like I could do that. It's not worth it. But the other thing, I wonder if I can chain the things instead of having to use 2 separate crystals. But again, all of this is a separate issue that I will get to in a moment. For now, let's try to get stuff working. So back to coding, I'm going to assert this part over here for now because this is still, as I say, this. Well, actually, I can. Let's implement it properly. It's easier. So try first without having to separate scalar. If the divisor is more than 0x FFFF, we know that it wouldn't fit as a divisor. Then treat scalar. Scalar divided by 16 times the baud rate. Actually, I can probably do that by 4, right? Because if I do this, x equal x times 4, yeah, it's still the same. divisor is more than 0xFFF. Oh, because that's not an integer, right? So I want that, and then I'm going to get the integer as a divisor. If the divisor is more than that, prescaler is 4, and divisor is going to be divided by 4 again. Divisor is going to be int divisor, because now I want it as an integer. And then if divisor is still more than 0xFFF, which is unlikely, but it could be, then I can raise value error, unable to find it. Actually, I'm going to do if divisor is more than that or divisor is 0, because that way if I pass the wrong value here, like if this one was going to be 120,000, well, okay, that one will be fine. It was like 20,000. Yeah, there you go. If I was trying to ask for 9600 bauds with a 20 kilohertz clock, I will be failing, and you want to make sure that that's actually taken care of. Like there is an error for that. Format. Baud rate. Okay. So sorry if you hear sirens. As usual, it's the M4. Now the only problem here is I actually need to set the divisor. So the way I set the divisor is by set the MCR7. Browsing again. And the MCR modem control register. No, that's the line. Where do you go? That's the modem. This one, if logic 0 divided by 1 clock input, and if it is logic 1 divided by 4 clock input, the rest is the IRDA mode, the exon, and the enable loopback, which is internal. But so the RTS, I'm going to ignore most of these. So instead of setting the prescaler to 1 or 4, there you go. So that's a prescaler. So I'm going to go CR value equals 0, because we'll start with 0. Everything else should not be needed. And if the divisor needs to be MCR value is going to be 0x80. Actually, I'm going to add 0x80 to that one. Let's set the prescaler. We set the divisor, and then we self write rag MCR, and I'm going to do the MCR value. Okay, so this part should work fine. This part over here just implements a read and the write rag over there, so that part is also fine. And those things are all passed around, so that part is also done. This one should be working fine once I copy this over. The next problem with that is, so this provides enter alpha in baud rate. This doesn't, I don't know how to write more than one. Transmission control register. those are all the, okay, there is the auto TRS control, output inversion, which I think that's what oh, all those are keyword arguments as well. So the output beam for RS485 direction settings, that's not something that is going to be. Okay, this supports some stuff around the auto address selection for RS485 and a bunch of things like that, which I'm not going to use. This is sub-addressing, it's a register address, and then that's end data. Let's acknowledge. Master writes to save. Register write cycle. The start is followed by slave address byte to direction set to write and sub-address byte and number of data bytes and the stop signal. Number of data bytes. So I think that means I can send more than 1 byte at a time if I enable the FIFO. So how do I set the FIFO levels? Because I want to test all of that. That's part of what I want to try. So FIFO, for now I'm going to just go for FIFO levels. Transmission control register. This is actually where, no, that's not what I'm writing. Where I'm writing when I write is the transmission hold register, which is at least 1 byte. Okay, let's start very simple with all of this. Let's start extremely simple with all of this. I'm going to bring back logic. And I'm going to see if the modified code that actually sets all the parameters based on the inputs work. So I'm going to close this one. And of course, this doesn't import name I²C because I didn't actually. I'm going to split this with a Tmax on this side. This doesn't have my Tmax config, but that's all right. I'm going to do devel repos flamize CircuitPython. I'm going to copy this thing in media CircuitPython to do it this way, and I'm going to cp -r. Okay, so if I now exit this, I²C object has no attribute device. Oh, because I need to set the device first and then I need this. Makes sense. cp d. No, I²C device at address 0x4d. Now, this is an interesting problem because let me see if the starting this works. I may have to, yeah, that's disconnect the thing, so I need to. So this one is not erroring out with no I²C address. The problem now is that I need to reconnect the media. No, I'm not showing it. If I actually go into analyzing, let's see if it's actually doing anything at all. Doesn't look like it is. If I Ctrl D reload, yeah, it says nothing on address 0x4d. this was working earlier. This up here was kind of working. You can see that there is like, something clearly not working right. There is nothing hot to attach, but clearly there is a little too much noise here. So I'm going to remove this. Adafruit link M0 SCL SDA pull up, and I'll see which actual you must add 2.2 to 10 kilo ohm pull-ups on both of them to the 3.3 volts. And I expect that to be the case. This should be 2.4K, which should be within the parameters. But let me try a different one. I have... Oh, wait, were these 3K9 rather? Yeah, these were 3K9s. Somehow the 3K9 is not working. Let me try the 2K4. It still says no devices. Now the problem is that they say these are not cheap, and I hand soldered them, but it looked fine. Like there are no shorts on this thing. And it was working fine the first couple of times I tried this. Now what this may be the case is that it gets stuck. But again, it says there is nothing on that address. And I don't really have an easy way to test what's going on there. Let me try again this way. Yeah, it says nothing is running. This is a questionable one, but that's going to also be very bad because, as I say, these are not easy to hand solder, so having to deal with it is a pain. This also says that one of these two was working, so if both of them are now erroring out, it means something else is wrong. Let me reset this again. Okay, now something is working on this one. But I don't see the output either. Like that's 0x55 as I requested, but now it sends it again and this one is not doing anything. And now I got an input-output error while trying to read this. Okay, so something is definitely not working right. Let me remove this. I'm going to be checking the other board as well. Oh, look, something is being sent now. But then it gets an input output error. Did that not get an acknowledgement? Did it get an error? Do I get what the error is when that happens? It is a NAC, so it's knacking it. It's knacking my write. And then it says that there is no device. This is not hot to attach. Okay, so the SDA is clearly better with this. Let's stop this again. Okay. Clearly something goes on when I try to detach this. I'm going to wire the RST pin of the feather to the RST pin of the TSOP. And I'm going to take this out for now. That way it should give me the same behavior either way. I have a short enough blue one. I don't want to cut another blue one that I might have to. The reason why I'm going for blue is because yellow and green are already taken by SDA and SCL. I don't want to confuse myself. Okay. Let's play this again. It's just a power on reset the problem. Because now it works. Okay. I'm going to detach this now. Everything goes back to down. I think it may just be the power on reset then. I should not leave that floating. Yeah, both of these T-subs work. That's great. And they are working exactly how I expect them to. So you can see here there is a ACK because I'm writing to the 4D and then I'm getting like that. So that part is working. Let's stop this for a moment. Now the question is, can I write more than one at a time? This okay, let me go back to the code for a moment. Okay. Yeah, it has different cameras, right? Sorry. Okay, so right track, I²C write, buffer and chew because it only sends that one But what if I want to write more than that? So I²C peripheral. Is that what I'm getting? Because I'm getting I²C device. Oh, that's from Adafruit bus device. And this then does a write. Let's avoid the locations. So if I want to write a long buffer, I need to allocate more than the buffer I'm sending. So I'm going to do assert len buff less than 64. No, less than equal 64. Because that's a FIFO. Anything more than that, I need to slice myself. So let me do one thing at a time. I'm going to be output buffer is going to be a byte array 1 plus len buff. Output buffer 0 is going to be ragthr. No, actually it's going to be So that's right rag, and that's the right rag 8. That's going to do all of them. No, it's not going to do all of them. That's going to do it. Def right rag bytes register buff. And I'm going to write it here, def right rag bytes. Oh wow. Coding, sorry. Sorry, I need the stream to experience it on white like bytes tongue. This has worked. I love this. Start.device I²C. Here's where here I need to actually allocate the buffer. I may have to start allocating the buffer there as well, because I don't think I need to be able to lock that buffer otherwise. So this part is going to be output buffer is going to be 1 plus the length of buff. That's going to be ragthr or register to XFF shifted by 3. And then I'm going to do I²C.write buffer. Actually, no, I can do I can make this buffer and byte array of 65, because it reduces the allocations. I need to lock the thing because it's not reentrant or thread safe, but that's going to be good enough. So output buffer 0 is going, or rather buffer 0 is going to be bad. Buffer 1, comma len buff plus 1 is going to be buff. This might work or might not, I'm not sure. And this is going to write the buffer and equal len buff plus 1. So if I do x equal byte array 5 and then x1 colon 3 4 sorry equal foo, well sorry equal b foo, yeah, that works. So all of these register buff stuff, all of it should work fine. Oh, that's fine. Self, self, self. I forgot all of those selves. And on the right, I'm going to do self.write reg bytes, reg thr buff. But that also assumes that I have a FIFO. So what I'm going to do, I need to be able to set the FIFO levels, because I think, well, let me connect the drive. And actually, given that we are now over 1 hour, I'm going to take a brief break after this one, just so I can grab something to drink. I'll be right back. And I'm back. Okay, so now I should have the CircuitPython again. I can copy this over. Let me go back to the analyzing. And let's see if this still works. Seems so. Okay, the buffer is still sending, everything is fine. Now if I go back to the code, just changed it so that it sends separate bytes. So it sends the 0x55 again, like before. There you go. This is the setup and then the write. And then over here, so you see 535 and the 25 because it has a setup as well. These 5 is 3, like this is the 0x55. Here there are 2 bytes that it's sending. So if I click on that, it's 0xAA, 0xAA. That is not what I was thinking. Because I did say 3 bytes, not. Oh yeah, I am sending 3 bytes. 3 bytes. AA, E, AA. But I'm getting only AA. So that is interesting because like, because I guess what's going on is because I disabled the FIFO. So the first writes, the second and shifts into the register, the second is lost, and the third one sends. I need to enable the FIFO for that to work. So what I need to do is to add code to manage the FIFO. Go back to browsing for a moment. It's a 64-byte FIFO, which you need to enable because by default it's disabled. There you go. This is what's going on. Now, what's a hardware flow control? But essentially, if oh yeah, and then these speaks I²C for 50 compatible registers. Kinda. Or the I²C bus. And the 16C for 50. It's a very old interface. It's more expensive even. This is without FIFO. Maybe the version with the FIFO. And I don't know if it is standard with that. Anyway, the I²C bus is just meant to be the... oh yeah, it has the pull up if you want for VRQ and stuff. I don't care of any of that right now. I don't need it to be compatible with anything, to be honest. After reset, where was it? After reset, both transmitter and receiver FIFO are disabled, and the trigger level is the default value of one character. And the selectable trigger levels are available via the FCR. The programmable trigger levels are available via the TLR. If TLR bits are clear, then selectable trigger FCR is used. So FCR or TLR. That's the trigger level register. That's a FIFO control register. So let's go and see what it says. This is the FCR RX trigger level MSP LSB, FIFO reset, FIFO enable. So these are the flash, and I think that this one after receive. So THR is the one where I'm writing, right? Yes. So it says that I need to, after receive FIFO or transmit FIFO reset, the user must wait at least twice the T clock of xtal1 before reading or writing data to LHR and THR respectively. And I assume that's what's going on there. Because I'm writing too fast. Like, there is no FIFO right now enabled, which means I only have a FIFO of 1, and I'm writing 1 without waiting for the next one to go. So, for this to work, not analyzing, but coding, there we go. For this to work, I need to know the FIFO. So, I'm going to call this tx FIFO for now, because I'm only sending tx FIFO equal the integer, and it's going to be by default none. It should be optional integer, but I'm not sure how to represent that. And then I'm going to have to set this. So this is the FIFO control register FCR. There's also an IIR. No, IIR is something else. So the FCR FIFO control register, there you go, this is the one I want. My default is disabled. I'm actually going to have RX FIFO and TX FIFO because it's easier to set up that way. I'm not going to do resets. Oh, and those are the triggers. The FIFO control register doesn't tell me the size of the FIFO. What is telling me the size of a FIFO? Aha, it's a transmitter FIFO level register or the receiver FIFO level register. Which is 0 to 64, and that's just straight out. Easy. And it looks like the THR sets a trigger level for one or the other. That's the reset. Let's enable the transmitter receive FIFO. They can, or both needs to be enabled at the same time. And I think one of these is IIR is the not IER, interrupt identification register. Okay, part of it mirrors the content of SCR0 somehow. Okay, that's the interrupt source, so it does the cannot be read as a burst. Oh, and there is a trigger level register that is. So if I enable the TLR, then it has the trigger level register. Otherwise, it uses the FIFO control register. Then this is the okay, because the default is in bundle of 8. I find this part extremely confusing. So the RX and TX trigger sets the trigger level for TX FIFO. When EFR4 is set. And what's EFR4? EFR4 is enable enhanced functions. What FCR? But it can only change. Yeah, it is. Oh, glory. Okay, let me try to understand what's going on here because this datasheet is complicated. So THR and RHR are the transmit and receive register, hold register. The THR is actually a 64-byte FIFO. The THR receives data and shifts it into the TSR, where it is converted to serial data and moved out of the TX pin. If the FIFO is disabled, the FIFO is still used to store the byte, 1 byte. Characters are lost if overflow occurs. So by default, this is 1 byte, but it can be up to 64 bytes because it has a 64-byte FIFO. Same thing for the read one. If FIFO is disabled, location 0 is used to store the characters, otherwise it's not. So I want to enable the FIFO. So the default of that is the RX trigger or the TX trigger. So what I'm going to have is, if I enable the FIFO, it needs to have an RX trigger and it needs to have a TX trigger and a TX trigger. But I can only change the TX trigger when EFR4 is set. I can change the RX trigger, but not the TX trigger somehow. This one cannot be set. These two are going to be even like, I'm not going to reset these unless I need a reset. So I think I can just enable the FIFO and this will have an RX trigger. Now the RX trigger, by the way, okay, FIFO reset requires at least 2 XTEL clocks. Surprise. Cannot be reset without the presence of XTEL1. Nothing works without XTEL1, it seems. The other thing with this if I'm not mistaken, the TX thing is only used, the TX the RX trigger is only used to trigger the interrupt. So you can still enable the thing and read 64 bytes just fine, just it's not going to have as many. So you need to actually read back how much you have in the receive hold register to know how much you can read out of it. And the line status register, this is the actual status, and this will tell you if THR and TSR are empty. Oh, it tells you if they are empty or not, so you can decide whether you can send or not. This one is to see if there is a break condition on the line. There is a FIFO data error, or framing, or parity, or overrun, or data in receiver. This one is the one that is telling you if there is anything or not. It tells you that there is at least one character. One of these should also tell you how many characters. I forgot which one. I'm not implementing the read yet on this thing, so that's going to be fun. These are the trigger level register, and this is also used for different, like this is for the, oh, there you go. This is the read-only register, but it tells you how many spaces are there in the, this one is the TX FIFO, and this is the RX FIFO. So what I'm going to do is, I'm going to have, instead of TX FIFO and RX FIFO here for now, I'm going to start with FIFO bool equal false, because by default it is off, so I'm going to keep it off. And then I'm going to actually, this is part of the FCR value, so I'm going to do FCR value equal 0 if FIFO self.FIFO equal true. Actually, I'm going to do self.FIFO equal FIFO, and I'll show you why later. And then if self.FIFO FCR value, I'm going to add 601, which enables the FIFO. And then I'm going to write create reg FCR value. So that's going to write the FIFO and enable the FIFO. Then I need to be able to read the transmit level when it transmits. So transmitter FIFO level register reports the spaces. It can be from 0 to 64. here. While buff. TX level is going to be self read reg, and the register is TX level, so reg TX level, yes. If TX level okay, now I need to decide how I'm going to send this over. I will not do a loop. I'm going to read the TX level. I will see how much. So with self dot. Oh no, let's see this later. I'm going to read the TX level. And then TX level is going to be 0 to 64. So space is going to be the minimum between the len of buff and the TX level. And then I'm going to write reg bytes, reg thr, buff space, the colon space, sorry. And then I'm returning space. So if I do it this way, if I'm not wrong the way I'm doing this, and I'm going to print the UART byte here. So if I'm right on what this does, okay, this is always going to return 1 and 3 because I haven't copied the right things. Ah, it's still sending 1 and 3. Okay, let's try to figure out why, because I don't think this is correct. Let's go just straight to analyzing. Okay, let me look at what's going on here. So the problem here is that it's telling me 3, but it's only sending 2. You see 0xAA, 0xEE. It's not sending all 3. But it's also interesting because now it's doing ACK, and then it's waiting to send the next, and then it's doing ACK again. I wonder why? I don't think there is any particular reason. This is reading. Oh, it's getting a knock when reading. That's interesting. Is that? Right. To 40. ACK. No data. And then it's writing that. What is the ACK? And it's writing the lyrics E. Okay, that's interesting. Let me try again. I mean, it clearly is sending not enough data because this should be about 0x55. That's fine, that should have 2. Is this now always sending it this way? It is always sending it this way, right? Yes. Am I not reading the register correctly? Yeah, now it's sending. These are bunched together, and so it's writing 0xAAA. Because doing it too fast. There is no space in the FIFO for it to do it. So this is a register number for the writes. So 1, and then it sends, and then 2 and 3, and then it sends that. This is the read that I expected. The X level is UX08 moved by 3, but is UX40, so that's alright. That's the right one. Is it because the FIFO is disabled and that's 0 one? Well, let's try. Coding. I'm entering the REPL, and I'm going to do pretty much all of this. Now I have my board, and now I'm going to do my UART SC16 IS741A I²C X4D FIFO equal true. So I'm going to listen in on the analyzer here. UART.write be hello world. It just told me 12, and it did indeed send 12. So if I go back to analyzing, stop. Yeah, there you go. That is hello world. This is also very clear, by the way, that this is how this is important. Like, BAT sent has a much higher speed than the baud rate. And in the meantime, like once this is written and it's accepted by the UART, you don't need to care about it. So this is sending it. BC is still getting a knock. Now what I'm going to do, I'm going to write this 8 times. And I'm doing twice. So both times it told me 64 because that's how much it wrote. And that's fine. Like I wanted to write a partial and just tell me, yeah, that's fine. That's how much FIFO I had. And then wait. But now I want to do something slightly different. I want to do it twice, but without me having to type it twice, because that will be too fast. Alright, too slow for me. Let me open a new one. I'm going to listen in, and I'm going to do this. I'm going to stop. It sent 64 and 15, because the second one didn't manage to actually get enough. So is this actually the NAC correct? 0x0f, yeah. There you go. So the first one managed to fill in the whole thing. And then when I went there, it was like I managed to send only a few of these, or I managed to, yeah, managed to send probably just the 15th at that point. So I only have 15 bytes, 3. This is working. This is great. This is working. Now, the problem is I need to try something different. I'm going to do this. Terminate again. I'm going to open a new session. I'm going back into my REPL, and I'm going to again set up my I²C. I'll show you now. I'm going to create my UART as an SC16 IS741A. I²C 0x4D. I'm going to do FIFO equal true. I'm going to do baud rate equal 104. That is the speed I want to send it. And now I'm going to UART.write. I'm going to send 55 AAE. Oh, I need to import time is already there. Time.sleep 1. UART.write 55 AA EE. So I'm going to send it twice. Actually, I'm going to send it in different orders so that I know that both of those are right. To listen on it right now. Oh, and this one failed. So let me stop this. It initialized. It actually asked for the thing, and then like it asked for the size of the FIFO, and then it errors out. Okay, it says it sent both, but I forgot to open the analyzer, so I'm going to redo it. Okay, I'm stopping this. Let's go to the analyzer. Here on the analyzer. Right, folks, just give me a second. I wanted to. Yeah, I'm still here, just checking something out. To make sure I'm not leading myself into a corner. Okay. No, that should be fine. I was running a couple of numbers just to make sure that the speed of the I²C wouldn't screw up with like when I have two UARTs. The same thing. Now VC is going to error out because the sync serial here. I'm trying to do this at 9600. I'm going to slow this down to 104. But there you go. Again, see the speed that you send it over the I²C bus compared to the speed of sending. It doesn't appear to need anything, even with the FIFO enabled, so it works fine sending 3 bytes. The distance between starting to send the first byte and that one is like, remove this one. If I set this one as T0, yeah, it's less than 1 millisecond. So that's perfectly acceptable. This one works great. I don't have any problem. I just need to make sure I do enable the FIFO, otherwise this part is not going to work. I'm not currently caring about any of the other stuff because I could set the trigger levels and all kind of things. Most likely, most people don't care about that. Now the question is, how do you manage to send these correctly if you don't use a FIFO? I still want that to work, at least on the CircuitPython code that I'm going to publish. So I'm going to have that in a moment because I want to figure out that part. So this one works though, and that's the important part. As I say, this will actually tell me if the FIFO or the if a FIFO is full, for instance, and it will send me let me send a partial message. So that part is awesome. Oh, this one has moved. So this one works great. This part works fine. The reset line I need to connect because there is power on reset. I need to have it connected, otherwise it doesn't reset. I probably want to actually have this controlled so I can reset the line manually. The same way as I do on the, I could connect it to something else on the trinket just to make sure I can reset it. I can reset it on the ESP32. On the ESP32, I actually explicitly put GPIO to the reset line of the TSOPs of these SC16s because I want to be able to reset them separately. One of them I may actually keep not running while I'm doing over the other stuff. I want to just keep it in sleep mode. So all of that is fine. The next step, I need to be able to read as well. So let's start and connect this to something. I have my serial adapter with a harness. I need my extension cable. Use this extension cable. The reason for it, the reason for that is that I'm connecting this to my NAC, which is behind there, and it's hard to reach. Here the serial. I am going to just connect the ground, RX, and TX. I don't need to look up where they are because I have the labels on them. So ground on the ground. And then the RX is going to go on the blue because the color of the UI and the... Ooh, this is going to be tricky. I should have put reset line somewhere else. Let me work this around here. So the color on the analyzer UI matches the color of the cable over here. I should probably just... I have been considering getting myself a camera clamp so that when I can put it top down instead of showing it this way. That way you should be able to see me moving stuff. To be honest, there are not that many people watching this, and like most of the other stuff I bought, I can reuse for other things rather than just this. And so I have not really worried too much, but like the camera clamp would only be for this. So the TX on the UI, you can see it's on the purple line here. And the cable that I have over here matches the UI one. So that's going to be my RXD for the USB to serial, and this is going to be the TXT for it by exclusion. Okay. Let me make sure this still works if I do it. Yeah, I see stuff going out. Oh, but it's not the right thing going out. What? That's UXAA, and that is UXD5. No, that's probably me just messing stuff up, I guess. I hope. Let me reset this. Okay, so this time it's also like everything is broken. Well, beside this is now set to 104, and I need to... I cannot edit the analyzer during the capture. This one goes back to 9600. For now, let me just keep the 9600. It's going to be easier. Okay. And this again is not sending the right amounts. So you see this sends 2 bytes and instead it's telling me that it's sending 3. So let's try to fix that. Browsing for a moment. So the important part is the THR and the TSR. Because the THR is the register that includes, you see here, actually the one before I think has more details. Yeah, this says receive, this is for VSTA, yeah. Transmit, interrupt, clear. Receive, interrupt. That's for the interrupt side. I'm not implementing any of that right now. Like, yes, there is an IRQ, but for now it's fine. Yes, PI writing. So one of these will tell me transmit FIFO empty, FIFO disable, or transmit FIFO pass above trigger level, FIFO enable. So if oh no, that's the interrupt. I don't care about getting the interrupt right now, right? Sleep mode. Yeah, if I read the line status register, it will tell me if THR and TSR are empty or if THR is empty. All I care if THR is empty, because if THR is empty, I can actually write. If THR is not empty, I can't. And if FIFO is disabled, I need to be able to send one at a time. So I need to be able to read the LSR. I need to figure out how to do how to mount something without having to manually go and mount. UDISC mount command line. UDISC CTL, maybe. Let's try. Status. Mount. STC? No. Mount. Yes, options. Great options. BSDC? No. Dash B serial maybe. Looking up object doesn't work. How do I do this? Oh, it needs to be dev STC probably. STC1, STC1. Somehow this one required. There you go. Okay, so I need to be able to read the LCR as I was saying, and I need to see if THR is empty or not. So, oh, sorry, LSR. I'm going to hide a few more of these things. Def property, def text level, self. So that's bit 5. So it's going to be 1, 5. So is it X choose 0? 1, 2, 4, 8, 10, 20. Yes. this wraps around the transmission level and should allow me to send this separately. Let's see. If I copy this, wherever this works, it reloaded. There is no read drag because this. What do I mean there is no read drag? I copied it from there. Oh, it's underscore read drag. Of course it is. Return. Yes, now it sends 1, 1, 1, 1, 1, and if I check the analyzer, it's sending only AA. So this works. Essentially, it says I'm going to have space for one, but not for the other. I don't know why code stopped by auto reload because I didn't reload it. So that's very interesting. So what I can do here is oh yeah, so buff is going to be this thing over here. That's my buffer. While buff, or rather, cent equal 0, while cent less than len buff UART cent plus equal UART dot write b cent UART dot buff cent colon. Okay. Oh, and on this side, I probably just want to make sure that if space I write, otherwise I don't. It's pointless to try to write just the register. So if I do now this thing, it will show me that it's sending all 3 bytes. Like it works actually. But here it writes here and it says 60. Why is it sending? Oh yeah, 60 because it says like there is the thing is empty, so you can send. There you go. Then it tries again, and this one it's empty. You can send. It's empty. You can send. If I was going to send more of it faster, it will, or maybe at a slower baud rate, but will not work. But now it works because it sends all 3 of them. There is a little bit of distance between one and the other because it has to go back to read that. And that is very visible when you do this because I'm actually queuing it. But that will do fine for the other one because I'm buffering it, so perfectly reasonable, perfectly fine. This part works. Now I'm going to stop this for a moment. I'm going to also create a new window here. And I'm going to open another TO. Actually, no, I don't want the TO because I want the character generator to that. But I guess I can. The I²C 0, which is not the ACM 0. This is the actual device. And can I get TO to I remember there used to be a way to just generate like A to Z. I guess I can write it in Python, but I really don't want to. Okay, let's write it in Python. It's going to be quicker to figure out. Import by serial with by serial.serial .ppi USB 0. Let me try to remember what. But it actually maybe this one had the character generator, right? No, it doesn't. No, it doesn't. Import serial.pti 0. 9600 for now. While true. Car equal A. Actually, while true for car in range A to Z. This should work, right? I'm going to do this one like test alphabet gen.py. I don't remember if it works. Range A to Z. No, it doesn't. Okay, so I'm going to have to do it the good old way. Okay. I want to enter again the close this one. Do I have VM? I don't have a VM. Okay. Python VM. CircuitPython and CIS 16IS7XX. Okay. Going to upgrade pip because I know what always is needed. Installing PySerial. And now Python test alphabet gen. Unicode strings are not supported, but fine B. Okay, I can see from the. Oh, did this one turn off? This one did turn off. Is the battery flat? The battery is very hot and flat, so I assume that's a problem. Let me just fix this in like real time. So, yeah, this is the battery for the iPad I was using. And it's not the greatest of idea of trying to do these things with the battery. On the bright side, I'm was not completely silly and getting a light that only works with a battery, it also works with a power supply. There we are. What I did not realize is that, so this is the battery, and it just changes power depending on like whether you're on battery or light, which is a bit annoying. Anyway, you can now see the thing is sending. And if I go to analyzing and take a look, channel 6, which is probably doing the wrong, it's trying to decode it at the wrong speed, is receiving, the other one is sending. I'm going to stop this for a moment again. So this one is also waiting for 104. No, for now I'm just doing 9600 because it's easier. Although it seems to think that I'm just sending zeros. 96, 8, and 1. Yeah, that's fine. Oh, that's our serial. What this one? Channel 6, yes. 96, 8, and 1. Yeah, that's fine. It thinks I'm just sending 0, 0, 0, 0, 0, which I may be doing, but it's not what I meant to be doing. What if I disconnect the cable from RxD? Oh no, that's TXD. Sorry. What if I remove RxD? And well, what if I remove both? Let's put it this way. I'm not listening to it because it's not connected. That's what. Yeah, so since I'm not listening, I don't need to connect TXT. I need to connect RxD. But you can see that something is wrong, like it goes down and never comes back up. I think that's because I need to put a pull up button. So I'm going to disconnect this chip for the moment. I'm going to put the pull up. I'm going to take it from here to here. I'm going to take a yellowish, no, I'm going to take an orangey. As always, live breadboarding, because that's what I'm doing at this point. Okay, so I'm going to pull up that over there. That should be the RX line. Going to add this one and this one. Still sending zeros according to that thing. If I disconnect it, okay, if I disconnect these, what do I get? Okay, so I'm getting zeros out of serial port. That is interesting. Oh wait, this is still connected. Okay, let me try. There we go. Now, if I just look at this one, I should be getting my input here. I'm sending A, instead I'm not. That is very interesting, thank you. Because, stop, play. Yeah, this is not at all related to TSOP. Like if I just do this, if I do these right now, I just connect TXT and RXT together. On the blue thing. It's not reading it. Something clearly is not quite working. That's ground. So the ground should be connected. And should be completely unrelated to everything else that is going on. And it is that for 3.3 volts, so everything should be the same thing. Okay, let me disconnect this again, and I'll try a different one. Because this makes no sense, it should just be working. Thankfully, I have more. This is a CP104 base one. Sorry, CP102 base one. I don't have a harness for this one yet. So I may want to create one. And I do have cables for it. I take this one, I'm going to be taking black, white, green, and purple. These are much longer cables, but that's actually possibly good in this context. This is actually 5-pin, and there is one past ground. That's a bit annoying. TXT and XT ground are in the middle, and then +3 and +5 on the sides. I'm going to probably not use these for now. I'm just going to use one of the normal cables, which are here. And the reason for that is because, well, one thing at a time. So this is 4 of them. I only need 3 technically. These three will do. I'm going to make the ground brown. Okay. TXT is orange, and this is and this is brown. To just plug this in so it doesn't move. This is now connected. It's still USB 0, so my TO session got just recreated. It sees 0xFFF. I'm not sending 0xFFF. Is it the blue connector that is the problem? It sees a freak load of noise despite me having connected the grounds. Okay. Time to take the multimeter out. So, if I assume that this one is ground, how many volts are here? 3.4. How many volts are here? 3.3. If I now start sending, this doesn't change at all. Okay. I'm exiting this. I'm restarting the alphabet gen. I'm going to disconnect this free. I'm going to get this cable, these two wires, female to female, and I'm going to connect gray to ground, white to TXT, and then connecting them on input 15 on the SALE. Then I'm opening a new session altogether and I'm changing all the configuration. I will clear this, I'll connect only 15. And I actually see something, but I don't think I see what I want to see. If I add a sync serial on channel 15, it sees all zeros. If I start this again and I connect TO, it tries. Oh, it's sending something. I think this may be just sending at 11, sorry, 115 200. But the case, yeah, so that one is sending fast, but it's sending. But 9600 is not sending right. So if I change this one to send at 115 200 and I start the alphabet test, Okay. I'm stumped. This should be working. Like, this is like on loopback. And it should be 9608 and 1 is the default. So let me stop this for a moment. This one should be set now to, okay, 9600, save. If I remove the other thing, does it change? No. What is going on? I'm disconnecting the salad and retrying because this makes no sense. Say 0. Okay, let's try something different then. Ground LXDX. And now instead of this session, which I'm closing, or this session, I'm going to go back to this session over here. Still get these like zeros. And now connect the LX to it. We're both blinking. The chip is not hot. Okay, was it PySerial being stupid? It was PySerial being stupid, clearly. Maybe, because I see B1, B5, AD. Let me just be... No, 9608 and 1. It should be getting all of these, not like skipping 4 at a time. Ah, that's going to be a mess. Let's try to go back for a moment to PySerial. Actually, before I even do that, let me just hit play again on this thing. Okay, some 0xFF, but it sees here. Jump to it. Yeah, it went down for just like a fraction of a second and then it went back up. That's just noise, it's not important. But the fact that it decodes it is a bit worrisome. See, now it's sending fine, except for those 0xFF. If I put a pull up, yeah, it's sending, except again for those spurious 0xFF that it reads that. I wonder those where they're coming from. Now, if I remove the red one and start again, yeah, that's still sending. If I remove these, still arriving, so that's fine. Okay. They still, as I say, a few 0xFFF, but makes no sense. Like framing errors on that particular line. Like, see this one, for instance. It should be a framing error. The question is whether the reading on the other side actually brings it over. Oh, so let's go back for a moment to browsing. So this is the serial API, PySerial API. If I go on to write method, it should return int the number of types written. But when I do this, Oh, I think that I know what's going on. Going back to coding. If I do this, print char is a number, and I write char, it returns the same value. It should be a number of bytes. Those are the actual zeros. What's in how many zeros it's going to send? Because that's what it's doing. But it's fairly silly to, like, if you're sending 1 byte, you actually need to have this as a byte. You need to send it that way. And that should work. That's what I've been following now for too long, trying to figure out why it wasn't working. You see there is still that 0xff there. I don't like that. I'm going to stop this for a moment. Close this. I'm going to go back to the other serial adapter because I don't like this one. Did anybody see where I put the other serial adapter while I was moving stuff around earlier? No? Found it. So I'm going to need not these two. Need to put these two over here so that they don't short random stuff. Because these are 3.3 and 5 volts. Going to ground this here. That's the TXT that goes on the LXT line of 1. And that goes over there for the RXT. To start the alphabet gen again, let me start this one. Let's see how this one is doing. Still see those 0xff. I mean, it's working, but sometimes I see 0xff there. I wonder what's causing that. That's not a very clean signal. But for now, this will do. I'm going to stop that. Now I have code gen running. Not the code gen. I have the alphabet gen running, but every second sends a character. This test alphabet gen here. So I'm going to close this one because I don't need it right now. Now I need to be able to read a byte. So the interface for read of the UART on this thing over here is read n bytes optional and return bytes. And n bytes is how many bytes, otherwise reads everything that arrives until the connection's timeout. Now the question is, how do I handle the timeout? For now, I don't have any timeout, so I'm going to expect the read to be there. Def read self n bytes option n bytes equal known. I'm going to return optional bytes, but for now this will do. This one returns it. If n bytes assert n bytes is not known, because for now it cannot support the n bytes known. And now I need to know how to read the byte. So the read the register. I know the register, but that reads the register. Write then read into, writes the register name, and then read into that thing. Def read reg bytes self register and bytes. This is going to be pretty much the same. The main difference here is going to be I'm returning everything after first element. Out and one, in start one, in end, one plus len and bytes. And this is going to be len and bytes. 1 plus, sorry. Len and bytes plus 1, because that's what I've been doing below. So this is going to read maximum n bytes, which is going to be at most 64. So I can actually do an assert here, assert n bytes less equal 64, just in case. And over here I can do an equivalent assert len buff less than 64. 64 is the FIFO, like that's the length of a FIFO. It cannot be more than that. Just can, like there is no way for it to. But that reads there. And then I need to know how many bytes I have available. So I need to actually have, I need to have the same here. Property def rx level self int is self dot FIFO return self dot read reg rx level. Yes. Else return one if self dot read reg lsr and else 0. I think this works. Let me see. So LSR, THR ready. No, it doesn't actually tell me if there is anything on the THR. Sorry, I need the RHR. Yeah. There is nothing that tells me whether LHR is empty. I assume that means it's always full. There's always one thing that you can read from the LHR. That doesn't tell me much, I guess. Oh, and I need to actually implement like declare this one over here. Actually, this should be less or equal. So if there is just enough in the FIFO, I'm just going to read them back. Otherwise, I'm going to... Well, I need to always return that pretty much, so I'm going to do that. Min n bytes and sub.tx level. No, rx level. So this should work, I think. Okay, let me try this one. So I'm going to send. I'm going to write, and then I'm going to read. Print UART.read. I'm going to do first one, then I'm sleeping 2. And then, yeah, I know it doesn't have a read for now. And then before sleeping again, I'm going to print UART.read 2. I know this will do it. And object of type int has no length. 9168 over here, len n, oh sorry, no, it's not len n bytes, it's just n bytes plus 1, and that is just n bytes plus 1. To another CP. So this treats only one at a time. Oh, because of course the TX level here is 1. So if instead I do this may read more than 1 at a time. Buffer must be at least length 1. Ooh, the LX level is always 0, is it? What is my level? Because it says at least 1, so... Let's see what's going on. So this is the... How was the code? Write, read, sleep 2. So this thing over here, that's a write. And there has to be a read somewhere here. That's interesting that the clock stays low that long. Why the heck does the clock stay low that long? Anyway, so this is set up right to... That's because the sleep happens while I'm doing that. Maybe. Oh no, because it thrown an exception and so it timed out. Okay, that makes more sense. Because that's trying to read. Oh, because it writes and then reads. Sorry, I need to remember that part. Any read is a write and run read. Because it writes the register. There you go. Write 0x48 plus ACK. That's write the register. And that is now read from that thing and it says 0. I wonder if that stays 0 or if it would have gone to 1 here. Do it this way. So this is going to be n bytes equal but if n bytes is 0, return time.sleep 0.2, return read self n bytes. Oh, space, not bytes. I probably don't want to do that. Let me just make it spin. Start that read. Oh wow, it will. Oh, okay, no, that's normal. Yeah. While true, space is that, space is 0, continue. Space more than 0, break, easier. Okay. Let's see if this one works. Okay, so eventually this thing goes to more than 1. Now what it gets is very random. But 0805, those don't make sense to me though. Ah. So here's the other problem with that. This is reading while it's changing. It's not reading it one at a time. It should be reading one at a time. This should be space, not n bytes. Now it is progressing correctly. So it's reading one at a time because that's all it can get. So let me just check for a moment the interface that it have. Yeah, it has a timeout, which is a float between subsidiant character while reading. Okay, let's try to implement that then. Because this is at this point nearly similar. So I'm going to import time. FIFO is still false, crystal stop. Where is the timeout? Timeout. Float equal 1. So self.time.FIFO is goes there. I'm going to set the timeout here. Self.timeout equal. Actually, is timeout a property? It is a property. So self.timeout equal timeout. And here, like this is going to tell me the kx level, or x level, sorry, this one is always going to give it x level correctly. So if and bytes is not known or timeout blah 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 blah. While true, if okay, so while true or not is not while true. So timeout. What's time.time on this thing? time doesn't work for this. Yeah, I need something different which is not time, to be honest. What we're seeing, I think it's monotonic and S. I don't think this has monotonic and S. Yeah, it doesn't. Time monotonic? Yeah, that will do. And time is going to be time.monotonic plus timeout plus self.timeout, while time.monotonic is less than end time. And eventually it will break. It's going to be write buffer is going to be byte array can I do that? No, I'm going to have to keep allocating this. So write buffer. This is going to be horrible performance for now, but this will do. That buffer is going to be this. Space is self dot minimum between n bytes and self dot rx level if n bytes is not known, else self dot rx level. So I'm going to actually cache it. A space is more than 0. Read buffer, append that. Oh no, but extend. No. Can you use plus equal? Yes, I can. This way I always remove the n bytes from, like I always remove how much I read from the n bytes. So if I need to read 50, it can do that. So this is going to be while oh, that's only if n bytes is not known. If n bytes is known, and keep going. Okay, if n bytes is known, n bytes equals 65k. 60... No, because they can actually do more of that. While n bytes is not known, and no. While n bytes is known or n bytes more than 0, there you go. If n bytes is not known, remove that, and time monotonic, and that's an end time. And then over here it returns read buffer. Let's see if it works. So if this works, I should always get consecutive letters there. Or maybe it's keeping one. Am I always keeping one? I'm always keeping one. Because I'm not fast enough, it seems. This is interesting. If I look at the analyzer, so I'm reading here. So that's the one that sends, and then it reads immediately. That's fine. Then one loses because it's time, and that's fine. And then it reads one, and then while it's sending those three, and it keeps pulling for the next, it seems to be missing one in the middle. Because I expect it's going to read this one, 72, and then it's going to read... I expected it to read 73 when this, because here it changes, and this is finally, oh yeah, there is one. And then I'm asking to read it. This one is 72, and this is 73. I somehow read 71, 73, I think. 71 would be G. No, sorry. 71 should be Q, and 7 QRST. So now I need to stop this so I can actually see what's going on. So when I ask Q is 75, which is U, and I get S and U, and I'm missing T, which is 74. So the one that it doesn't read, oh, because it's writing, I guess. The one that it fails to read is this one, 74. Okay, kind of makes sense. Kind of, not as much as I would think it to work, but it does to a point. Whatever. I guess it's good enough, as they say. Okay. I'm also keeping an eye on time because I'm doing 3 hours now, and I have a grocery delivery coming soon. So there is a little bit of that. Let me terminate this for a moment. Now I want to enable the buffering. So I'm going back to this one with FIFO. I'm going to do FIFO equal true. And this should always be contiguous. Yeah, there you go. Because now it's FIFOing, and like it knows that it has that much space, and so it will always be reading continuously until it overflows. Because it's sending faster than I'm reading it, I think. So with the hardware FIFO, this reads all fine. So this is going to be, I think, great. I think this is working fine. The FIFO level keeps increasing and a bunch of stuff like that, but I think this will work. This will do the right thing. Yeah. Okay. I think we are in a state where I can start setting this up as a repository. Actually initialize and start publishing some of these, pointing out like this is like very experimental, but we'll do fine. Oh yeah, sorry, no, the other thing I need to do is make sure this all works at 104 bps. Because 104 is special, and sometimes it doesn't quite work. I'm going to do this, baud rate equal 104, FIFO true. I'm going to do exactly the same thing, and on the test file that I closed, open, recent, open, close that, where you go. I'm going to send these at 104. Terminate this, and I'm going to start again. Oh, sorry, stop first. I'm going to change all of these to actually expect 104 bps. Otherwise, it's going to error out. 104. Okay, save. Let's restart this. I see that it's working in the background, so yeah, FIFA enabled and everything works fine. It works. It absolutely works. I am surprised myself. It actually ended up working fine. I'm going to start publishing this right now. Let's do that live. I'm going to keep this one in the repo so that it doesn't annoy me with the movement. I think this is perfectly fine. That's all the SPDX headers. Like there is very little of the original, but there is a little bit of the original on this one. There is none of the original in that one, so I'm going to just copy this part over here for the code, which is the example, and for the gen. And like all of this is going to be like I'm going to submit it as is for the most part. And I'm going to actually create one here. Examples. I'm going to put it here. Example.py. I'm going to just I want to create examples first, I guess. Okay, I will take a moment for a bio break and I'll be right back. I'm back, and I've got a parcel from AliExpress, and this is some of the cables, I guess. I expected a lot more cables than I got, so trying to open this without having addresses or anything. Yeah, it's very little amount of cable. I thought I ordered meters, not centimeters. Oh no, this is the silicone one. Okay, that makes sense. So this is very soft, very nice actually. Wire. These are the harnesses for the actual, like if I want to build the actual air control panel, because I have some waiting from DigiKey, but they're still not here. And these are some of the DuPont cables. And I do have like meters of wires still pending. Actually, let me see out of curiosity. So this one is that particularly express order. These are all 1 meter. Although I don't really look it. So I may want to double check that. They are supposed to all be 1 meters. And I think I also have some solid core wires. Ha! I now see the same kind of random electrical stuff that Big Clive was showing on his channel. Did I order the other wires at the same place? Did I order from a different place? No, these are the only ones I order. I guess I forgot to order the equipment wire, because I do need some solid core equipment wire as well. I thought I ordered it already. Oh well, that's going to be my next thing. Where were we? Oh yeah, this thing is nearly ready to be. I'm going to start very briefly. SC16 IS741 and driver 4 CircuitPython. Note this is a very early. Please excuse. I'm going to just add this other readme.md. I'm going to remove git add readme ref bundle and the fruit, but part of a bear right now I don't need them. And I'm also going to add the same. I'm going to move the MB test alphabet to example, called example test alphabet. Okay, this one already has a thing. Examples. I'm going to add it. It's going to be very rough there, but it's going to be needed for now. Its status. Activate VM. Git install reuse. Git status. Okay, reuse lint, use download all, use add header. Oh, I probably just need to let me do it manually. This is going to be over here. Okay. Lint. Yeah, great. Okay. And I don't think I have a repository for this yet, so let me create one off camera because okay, new repository, that's my repository name. To create a public repository, and I'm going to do this. There we are. Now we have a code drop for this. This needs a lot of work. Now, I also want to try a different thing before we go. Because I have, I really point this so that you can actually see what I'm going to be talking about. There we are. This is the piece of with the configuration with that particular clock chip. This is going to stay, and I'm going to move this one to the side. That clock chip is a 1.83 whatever it is, and it's fine for the most part. What is not fine is that I need 2, and those adds to the those add up to the bill of material, like annoyingly so. I should be able to get a clock out of the PWM. And given that I'm looking for 104 bps, I can actually get a decent enough clock without having to bother too much about that. But first I need to figure out how many PWMs output this thing has. So let's go and browse that a little bit. Browsing. I'm going to close a few of these because I don't need all of them right now. So if I'm looking for trinket M0, pinouts will do fine. Trinkets M0, and this is the graph of the pinout. Give me the whole thing, there you go. So port pin, serial pin, power, analog, PWM pin. Those are the ones with the PWM pin. So 3 and 4 are PWM pins, and so are 0 and 2. But 0 and 2 are used for STA and SCL, so I can only use one of these 2. And the other thing is I don't know. Not I was about to say I don't understand. I don't know whether I can run all 3 at the same time. I don't know if that thing is going to work the same way. So this helps as a first thing. The other thing I'm going to do is I'm going to add 1 more cables to the analyzer here because I want to see that log. So I'm going to get one of the cables I had on my desk earlier. I'll get this one. Oh, here they are. going to use, no, this is wrong. This is female to female. I'll use this ring. This should work. This three over here. I'm going to connect them over here. I'm going to use some extra this away for now. I'm connecting to the Sale on ports 8, 9, and 10, I think. On channel 8, 9, and 10. So let it go. And I'm going to use 8 for the clock, or rather for what I want to be eventually the clock, which is this one, number 3. So if I now add a fruit, CircuitPython PWM, there should be an example for the CircuitPython PWM. There you go. Time board PWM I go. And I'm going to do CLK is PNWIO dot PWM out port dot D3 because that's what I'm using. Frequency equal 12. I don't know what the limit is, so I'm going to try and do this with 12 megahertz. I don't know if it's going to work. Duty cycle equals 0x1FFF should be 1FFF, I think, is this 50% one. If I remember correctly, that is the so if I now go to the analyzer, I need to add one more, which is channel 8. That creates the output, maybe. Maybe, maybe not. I'm still not sure what I'm doing wrong. Does that actually work? Third clock. So if I try... Okay, so 12 kilohertz works. If I stop this, the 12 kilohertz should... Yeah, frequency of 12 kilohertz with a weight of 13, whatever, duty cycle 1248, so it's not 0xFFF, 1FFF, whatever it was. It's probably 7F. The other thing is I want to figure out how that looks with the original one, so let me add a clock. Actually, digit? No, I'm going to have to do this by hand for now. So if I add channel 9 and play, channel 9 happens to be a lot more often, like more complete, because it is a much faster clock. If I zoom in, it says that it has a duty of nearly 50% at a frequency of 1.8 something megahertz. And that's fine. Now, if a divisor is going to be the full frequency divided by the baud rate times 16, since my baud rate is 104 times 16 is this thing. If I do a frequency of this, that's my divisor. That may actually work. It's just a bunch of things depend on the timing of the clock. The other problem is I don't know what the maximum is. Trinket M0 PWM maximum frequency. Be right back. Sorry, timing. So I don't know what the maximum is going to be. As I say, there are a few things that depend on the clock, so let's take a look at what that is. That's a clock divisor, data transfer, clock pulse, but now what's for the I²C. Yeah, X.2, clock input. So X.2 should be left open when X.1 is driven by an external clock. Clock input max, yeah, that's the VDD. Like, okay, it says it's what volt. Doesn't actually have much. Yeah, there is something here which is like SCL delay time after reset, 2 extra 1 clocks or 3 microseconds. Oh yeah, okay. So that's what was going on. If the device was given power and the transaction occurs during the delay time, that was why it was erroring out. That's why I needed to actually connect the reset line. This one has somehow, this one knows it has an internal clock of some kind. Clock. Maximum 80 megahertz at 3.3 volts, because it can also operate at 2.5, but we're operating at 3 in this case. Crystal oscillator maximum 24, because it needs to oscillate it, so it makes sense. So it doesn't actually, I can connect an external clock. It doesn't tell me what an external clock speed needs to be. Clock input. FIFA reset requires at least 2 crystal 1 clocks. That's the thing. So assume that the clock is going to now be 0x7ffff. And let me see, can I do like 16640? Which would make it like perfect lock for me for this use. Channel 8 is, yeah, that channel 8 is the actual PWM clock, which is a 16640-ish kilohertz at 50% duty cycle. Perfect. Now if I do that and remove the actual external clock, I'm going to disconnect X.2, which is currently connected with the capacitor, and then I'm bringing a line in not blue because I'm already using it. I'm going to use orange again, despite the fact that I'm also already using that one. And I'm going to disconnect the other capacitor as well. Now I'm going to import board, time, and the I²C. But for the UART, I'm going to do this with the crystal clock of 16630. So this one is still coming from the computer, don't worry about that. But now I'm going to be sending hello world. There you go. That is hello world. And this is sent without actually having an external clock. Because this is me sending it with a perfectly normal clock. Now what you see here is a very small delay still. Like, it really doesn't make much difference. So I can drive this without needing 3 components, because I don't need the crystal. And I don't need the capacitors. And this is going to bring my test rig to like simplicity, because that means over here I can also replace it. And then it will reduce the bill of material when I'm actually doing the full thing. So yeah, I think I'll call it a day. The code is published, this thing works. That was the latest experiment I wanted to try with CircuitPython for now. Most of the stuff I wanted to try with CircuitPython actually worked out perfectly well. Oh, I'm not actually showing you the analyzing here. So yeah, this is, let me stop this. This is the computer sending data, but this is the important part. This one is the external clock that I'm generating, and it is 16747. This is the 104 bps signal, and it's generated based on that external clock, and you can see that it sends just fine. And the slopes and everything is perfect. So yeah, I'm very happy about this. As I say, it reduces the bill of material significantly. So great. This is going to also go into a bunch of blog posts, and then we'll see from there. Enjoy, everyone!